Any questions on the homework before we get started? Question on any of the homework assignments? Now, out of all the factoring that we do, normally students like this one more than most. Because what we're talking about today is special factors. And it's not so much that they're special in themselves, they just factor in an interesting way. Now, there's two of them I don't normally look at. And it's these two here. We call these two here a perfect square trinomials, because a squared plus ab plus b squared will factor to the form of a plus b squared, and that should be a 2. And this here would be a minus b squared. But for the most part, those there will factor like we do normally. They work out the same way that they normally would. So there's not a whole lot of emphasis I put on those there. But the one that is kind of nice and definitely we need to look at is the difference of two squares, difference of perfect squares. Because if we have two perfect squares being subtracted, we can factor it into the form a plus b times a minus b. So x squared minus 9, well, x squared is x times x, or x squared. 9 is 3 times 3, or 3 squared, and we get x plus 3 times x minus 3. Let's look at another case here, x squared minus 25. Well, the general form, a squared minus b squared, is equal to a plus b times a minus b. So we can write this here as two terms, two perfect squares being subtracted. Now, what times itself is x squared? Well, that would just be x. Now we need to see what times itself is 25. And that would be 5. Because we can write x squared minus 25 as x squared minus 5 squared. So for us here, a is x and b is 5. So as we factor for this first part, a plus b, well, a is x, so x plus b, so x plus 5, times a minus b, so it would be x minus 5. Questions on this here? Are we ready for the next one? 4z squared minus 1. So 4z squared and 1, we need to see if they are perfect squares. So if they are, what times itself is 1? 1. 1 times 1 is 1. What times itself is 4z squared? What times itself is 4? 2. 2 times 2 is 4. Yes. What times itself is z squared? Z. Because 2z squared, 2z times 2z would be 4z squared. So it is a perfect square. 1's a perfect square. So now that we have this, a is 2z, b is 1. So a plus b, so 2z plus 1, times a minus b, times 2z minus 1. And that's it. Questions on this here? Now we can check and see if we got the correct factors, because we can check middle terms. 2z times negative 1 is negative 2z. 1 times 2z is positive 2z. And negative 2z plus 2z is 0, 0z. We don't have a z term, so it is indeed 0. Questions on this here? X squared minus 64. Well, the x squared would just be x squared, so a is x. What times itself is 64? 8. So a plus b, x plus 8 times a minus b, x minus 8. So x plus 8 times x minus 8. Is it? Questions on x squared minus 64. X squared minus 36. So if we want to get it into that a squared minus b squared form, so we can see what a and b are, x squared, so a would be x, b would be 6, because 6 squared would give us 36. If we're not sure if it is a perfect square or not, we can always take the square root of that number, because square root of 36 would be 6. So we know that b is 6. So we get a plus b and a minus b. So this would be x plus 6 times x minus 6. Questions on this here? Questions on any of these so far? 100 minus m squared. So if we get it in this form, a squared minus b squared, 100 would be 10, m squared would be m. It doesn't matter that the variable went second and the number went first. We still keep it in this form. So a would be 10, b would be m. So we get 10 plus m times 10 minus m. Now we could flip it around and have m go first in each set of parentheses. Don't have to, we can leave it as this here. Questions on this here? We're ready for the next one. 9n squared minus 16. So if we get it in the form of the a squared minus b squared, what times itself is 9n squared? It would be 3n. What times itself is 16? 4. So we have 3n plus 4 times 3n minus 4. If there's a greatest common factor, we could factor it out. We can pull it out and then do this here. Sometimes we have to do it, especially if, with the greatest common factor, they're not perfect squares. I'm going to add something to this one here. Let's say 16h squared minus 49m squared. Now this one here, I've added a variable, but it's not really going to change anything. Because our 16h squared, 4 times 4 would give us 16, h times h would give us h squared, so 4h would be our 16. 4h squared would give us the 16h squared. 49m squared. Well, our 7 times 7 would give us 49. M times m would give us the m squared. So b in our case would be 7m. So has the process really changed for this here? No. Then we'd have what? 4h plus 7m times 4h minus 7m. And that's it. Questions on this here? 25b squared minus 36. So 25b squared would be 5b. 36 would be 6. Five b plus 6 times 5b minus 6. Questions on this here so far? We feel good with these here. All right. I'm going to add one. (32x² minus 50y²). So I added this to the list. What times itself is 32? Is there a number times itself that's 32? No. Is there a number times itself that's 50? And it would be? (5 squared of 2). So there's not one, but is there a greatest common factor between 32 and 50? Yes, and it is 2. Because if I factor 2 out, if I remove 2 from 32, we're left with 16x². If I factor 2 out of 50, I get 25. Now 16x² we've done already. It would be 4x. 25y² would be our 5y. Telling us that we have what? 2 times 4x plus 5y times 4x minus 5y. So if there is a greatest common factor between the two terms, and that greatest common factor is not a perfect square, we have to factor it out before we can use the difference of perfect squares. Now, if it had been a perfect square, it would have actually worked out nicely, because say the greatest common factor, we put another factor of 2 in, and that would give us 64x² minus 100y². So there's now a greatest common factor of 4, yes? Can I take the square root of 64? Well, yeah, square root of 64 is 8x² minus 100y² would be 10y², which will tell us that we have 8x plus 10y times 8x minus. It still works because the greatest common factor is a perfect square. Does that make sense? I have a feeling if you got this back home, they would either maybe not mark it fully wrong, but mark it wrong because that is not fully simplified. Because we will come across it. Fully simplified says that we cannot reduce it in any way with factoring. And the reason it would be marked wrong for not being fully simplified is because if we look at the first two terms, 8x and 10y have a greatest common factor of 2. They can be factored further. It's not fully factored. So we can take that greatest common factor of 2 out, which gives us 4x plus 5y. Well, there's also a greatest common factor of 2 here, which can be factored out, giving us 4x minus 5y. And our 2 times 2 out front would be our 4. That'd be fully factored. 8x plus 10y times 8x minus 10y is factored. It's not fully factored or factored completely. Because if they put the completely onto it, we have to go all the way down to 4 times 4x plus 5y times 4x minus 5y. That's completely. The step above is just factored. Questions on this here? Are you ready for this? Use a special product pattern to evaluate the expression 54 squared minus 48 squared. Now, if we were to try to do this without this special pattern, we'd have to first figure out what 54 squared is and 48 squared is, and then subtract the 2. But if we use this special pattern, A is 54, B is 48, we'd have 54 plus 48 times 54 minus 48 and simplify from here. 54 plus 48 is going to be 102. 54 minus 48 is 6. And if we multiply these two together, we get 712. Interestingly enough, the academics has thrown one or two of these on in there. This is all it's asking. Simplify the following expression and they give you two numbers squared. This is all it's asking us to do. Because just trying to do 54 squared minus 48 squared would take a bit. Here, 54 plus 48 times 54 minus 48, 102 times 6 is 712. So it's 54 squared minus 48 squared. Make sure I wrote that right. 54 minus 48. I carried a 1. That should be a 6. I carried the 1 from the tens place to the hundreds place. But, questions on this here. So 68 squared minus 62 squared. 68 plus 62 times 68 minus 62. 68 plus 62 is going to be 130. 68 minus 62 is 6. 0. 780. Questions on this here? That's it.